Hello everyone, my name is Sachin Shrestha and today I'll be sharing what I learned in this week software engineering lecture. The key topic covered with the capability maturity model, also known as the CMM, and its successor is CMMI, and the advantages and the disadvantages of the waterfall software development model. I'll also explain how its knowledge can be linked to my software engineering projects. So first, CMMI. Capability Maturity Model. The Capable Maturity Model or CMM were introduced by the Software Engineering Institute in early 1990s. Its purpose was to help the organization measure how mature and reliable their software development process were and to develop provide guidance for the improvement. CMM is divided into five levels of maturity. Level 1 is initial. At this stage, there is no defined process. Success depends on individual and sometimes even luck. Level 2 is repeatable. Here, the organization has mastered some basic processes like requirements, management, project tracking, project planning, quality assurance, subcontract management, and so on. Level 3 is defined. At this stage, processes are standardized and well documented across the organization. This includes training programs, peer reviews, product engineering, and integrated management. Level 4 is managed. The organization now measures processes quantitatively, which means it uses metric and data to manage quality and performance. Level 5 is optimizing. This is the highest level. It focuses on the continuous improvement through the activities such as defect preventions, technology change management, and process change management. Altogether, to reach the top level, an organization must master a total of 18 processes. CMMI, Capability Maturity Model Integration. In 2001, the CMM model was upgraded to what we call now CMMI, which also stands for Capable Maturity Model Integration. The idea was to unify and expand the original model so it could cover just software engineering, not just software engineering, but also the system engineering, supplier scoring, and integrated product development. CMM has 25 processes grouped into four categories: process management, process project management, engineering, and support. Another important aspect of CMMR is that it offers two different representations: the state representation and the continuous representation. The state representation is similar to the original CMM. Organization progress from maturity level 1 up to the 5 by mastering the state of the process. This allows user a comparison between organization. And the second, continuous representation, focuses on the improving each individual process starting from the capability level 0 up to the level 5. This allows organization to prioritize which process they want to improve based on their immediate needs. Both approaches aim at the making organization more reliable and consistent in the software development. The waterfall model, which is which is more popular than any other. Next, we will also discuss one of the earliest software process models, which is waterfall models. The waterfall model works in a linear sequence of the stages, requiring gathering, system design, coding, testing, and finally integration and development deployment. Each stage must complete before moving to the next, and the output of the one stage becomes the input of the next. This model has some advantage. It provides a very clear structure and easy to track. Managers find it straightforward to control the progress because each stage is clearly defined. It is also suitable when requirements are stable and unlikely to change. However, it also has a disadvantage. One major drawback is inflexibility. If requirements change, it is very difficult to go back to make adjustment. Another issue is that testing comes only at the end of the process. This means errors or misunderstanding in requirements may only be discovered very late, which can costly. Because of this limitation, the waterfall model is not ideal for more most of the projects which is done by the company or the organization. So it has to evolve over time. Application to my project. Now, how I can link these ideas to my software engineering projects? Understanding CMM and CMMI helps me recognize the importance of the process maturity. For example, even in the small student project, if I establish clear processes for requirements management, project planning, and testing, I can avoid confusion and improve the quality of the outcome. If I were working in a real company, applying CMMI practice would mean my team could achieve consistency, reduce risks, and continuously improve over time. When it comes to the process models like waterfall models, I can see this might work if my project has fixed requirements from the start. However, because student project often involves changes and clarification later on, a more iterative approach might be the agile. Even so, learning the water model is valuable because it provides foundation for the understanding more advanced model like incremental, spiral, or agile method. In conclusion, this quick lecture has taught me that the structured processes are crucial in software engineering. CMM and CMI provide a roadmap for involving in organization maturity, which while the waterfall models illustrate both the strength and weakness of early processes model, by applying this concept, I can make my project more organized and also prepared for the professional software engineering practices in the future. Thank you for listening.